Hello everyone, in this video we are going to talk about the transforms library from the HuggingFace. We will cover the library, we will talk about the pipeline function, and we will talk about the architecture under the hood. So the transforms library provides us the functionality to create and use shared and pre-trained models from the HuggingFace. So there are thousands of models in here. You can check out their GitHub page, and this is the model website that you can find, for example, 1.5 billion of models in here, and you can check out the class in here as well. So this library is easy to use and flexible because you can use TensorFlow or PyTorch and models. And the most popular function of them is pipeline. There are more than one functions, and we will start with the pipelines, and in the future videos we will talk about train as well and maybe the other functions. So pipeline is the great and easy way to use models for inference. We will talk about the text generation and text classification as well, and there are a lot of different types and we will talk about them as well. So let's first open our Jupyter notebook, which in here in our cursor IDE. So in here you can create a virtual Python environment for this, and you can create an IPython notebook. I also use an extension of Jupyter, this one. If you don't have, you can download Python as well. Yes, Python. And Python, yes, you can download Python extension as well. So let's come back to here. Okay, so from transforms, I'm importing the pipeline, and I'm saying to pipeline that I will use sentiment analysis, and I'm giving it a text. Season 3 of Invincible is incredible. Actually, I'm in episode 4, but for now it is going good. So I suggest you to watch it. So when I run this function, actually, as you can see, it is giving me that this sentence is positive with the score of 0.99. So there are actually a lot of pre-processing and post-processing when we are giving an input and getting an output, but pipeline function actually just doing those steps for us. But in order to learn what is going under the hood, in the next video we will talk about those steps as well. And as you can see, we didn't give any model. Actually, we just give the model type, the sentiment analysis. When we don't give any model, it uses the default one. So for the sentiment analysis, the default one is from Distilbert-based uncased fine-tuned SST to English model, which you can find model in here in the HuggingFace. I can just filter by name, and as you can see, this is the model. It is a text classification model, and you can read the details if you want to, or you can use it. You can use it with the transforms library, as you can see. So we can give multiple inputs as well. Like I can give 3 inputs, and one of them is negative. And as you can see, it says the negative. And the second one is zero-shot classification. It is an important classification because you don't give a labeled data to train. You just give it and say these are the labels, because we don't have just positive and negative labels. We can use different one as well. For example, it says Superman is from Krypton and he is the savior of humanity. And we have hero and villain labels. And as you can see, it says the hero. The other one's probability is very low. And the default model for this one is BART large MNLI, as you can see. So we have different default models for different types. And the next one is text generation for pipeline. And this time we are not using the default model. We are giving a specific model, and we are saying use tiny llama. This one has 1.1 billion inputs. As we can see in here, this is a tiny llama. It's pre-trained on a 1.1 billion llama model on 3 trillion tokens. They have trained it for 90 days, for 3 months. That's cool. So we are using the text generation. It is a text generation model, and we are saying Batman is a detective. Actually, we can just ask for to generate something, but I'm just giving a random sentence and see what it got. So it generated a text like Batman is a detective who is known for his quick thinking and his ability to solve complex cases. So it is creating me a story, or just giving me an introduction to maybe a comic book, or something like that. So the other one is fill mask. Fill mask is another model. It is a model to fill the blank sections, your words in a sentence, like Superman is from the planet something something and his name is Kal-El. This is mask, but in some models it is masked like this. It differs model to model, and as you can see, we are using a specific model in here, Distilbert based uncase. You can check out the details in here as well. You can just find it from the Hugging Face. It has, as you can see, it has 67 million parameters. So it is not actually a lot compared to models that we have billions of model size, but we can use it in our local and fast. So as you can see, when we run it, it says Superman is from Earth, or we are using the top key, so we just wanted the top two inputs or the results. It says Earth, and the second guess is Mars. As you can see, this model doesn't know where Superman is from, so it's a shame. The next one is named entity recognition. Near. So when we say the grouped entity is true, it is getting the data and it is grouping them based on some labels. Like when I say my name is Fırat, I am a software engineer and I live in Istanbul, it says the person is the Fırat and the location is Istanbul, and these are the details and location of the word. The next one is question answering. It says like when I give where do I live, and when I give the answer as well, like my name is Fırat and I live in Istanbul, like I'm trained, something like that, but I'm just giving a one example. And when I ask where do I live, actually I don't give the answer, I just give it the context, like the knowledge. And I give the context question and it gives me the answer and says Istanbul. It actually doesn't generate an answer. It is just giving answer based on my input. I'm not saying why it is not generating it, because it is an encoding type of architecture, and we will talk about the architectures later in the video. And the last one is summarization. So summarization is a different type of model, and we are saying maximum length for token is get the token for 130 and min length is 30. You can use different parameters as well. And we are using the default one. It is Distilbert CNN 12.6. And it is giving a summary and says The Dark Knight Returns is from 1986, which is 4-issue comic book miniseries, and it is a great miniseries. I definitely recommend it if you are reading a comic book. And this is basically how you can use the pipeline and you can start your NLP coding marathon. Hugging Face supports inference as well. It has an Inference API. Not all the models, but a lot of popular models use it and supports it. Like you don't have to use it from your local, you can just use it from here as well, but they have limits, so you can just test it before you download it. Like this is the Inference API of Tiny Llama, and I'm just using one of their examples and say write me a function to calculate the first 10 digits of the Fibonacci sequence and write it in Python and write it printed to the CLI. When I send it, now I'm using it because it is a text generation tool and it is generating one. But it says I can't write the code, but it was actually giving me, this is the second time I'm using it. In the first time, it gave me the code actually directly. So I will try it again. Oh no, it is giving me the implementation. Great. Okay, it's done. It gave me the Python code to generate the Fibonacci number, as you can see in here. So this is how you can use the inference UI, like the other models. Like this is the mask one. Yes, mask token inference API for Distilbert. And this is for text generation Tiny Llama. Oh, we already talked about it. But you can use it for fill mask as well. So let's talk about a little bit about the architecture of Transformers library. So we can think like we have three types of models. We have encoder-only models, we have decoder-only models, and we have encoder-decoder, or as known as sequence-to-sequence models. So let's talk about this a little bit. Encoder-only models are actually getting the data and just exploring that data, or labeling or grouping the data. This type of models like sentence classification or named entity recognition, like we talked with, like in here, like this one. It is just actually exploring the input. It is not actually generating a new data. This type of models are called encoder only, and when they are exploring the words, like season 3 of Invincible is incredible. For example, the of word is depends and more important or less important based on the location or the context, like what is the before, like what is the previous word, or what is the next word is, and what is the length of the sentence is, like a lot of things. So it is looking for the left and it is looking for the right. So it is called bidirectional attention or auto-encoding models. It is looking for the both sides, and it is called attention because it is looking for the attention of every word or every token, but we will talk about the tokens in the next section or the next video. So you can think like it is giving a rank to every word, like like importance, and attention is very important for the transforms library. And when they are announcing the transforms architecture, they gave the title, the attention is all you need. Attention is all you need. You can check out the links if you want to dig deeper about this architecture. So the decoder only models are just focusing on the outputs, like text generation. I'm asking for something, or I'm saying do something, and it's just creating something, but it doesn't getting the input, or it doesn't explore the input, like text generation. For example, when it is generating something, like then the model is trying to find the next word to generate the next word, like name. It is reading my name and generating the is. Then it is reading my name is and generating the fraud. It is always reading the previous word and then trying to generate the next word. It is just focusing on the output. That is called decoder only, or as known as autoregressive models. The third one is the encoder-decoder models, or called sequence-to-sequence models. They are getting the input and then they are focusing on the output as well. For example, the translation or summarization, they are getting the input, and it is not as simple as like they are just composing the encoder and decoder. It is more complex at that, but in basic, they are just a combination of these two type of models. Like I said, both encoder and decoder. So architecture of this encoder decoder is like this. In the first slide, this is looking for a little bit complex, but actually we will talk about the details in the following videos as well. Like we will talk about the embeddings, we will talk about the softmax, etc., etc. But basically, like we saw in the previous image, we have input, and we have an encoding section and we have a decoding section. And as you can see, in the second step of the attention, in the decoding, it is getting the input and it is getting that data as well. And then it is generating a new ID, a new word, a new token, or a new data. So what is the example of it? Like when we are translating a data, it needs to get the data, get the input as well. For example, the translation. For the translation, it depends on the input, right? It gets the data, then translated. So we have an input and we have an output. If you want example for this kind of models, for the encoding one, we have BERT. You can look for this model. For the decoding one, we have OpenAI. It is a great example for text generation or summarization. For the sequence to sequence, you can look for BART in detail. Like this is a sequence to sequence model. Like I said, for the translation, for example, this is proposed for natural language generation, translation, and comprehension. And this is basically what types of architectures Transformers library has. All this information that I have given to you actually coming from the HuggingFace NLP course. We were talking about the first section actually, and we will talk about the next sections in the next videos. But if you want to dig deeper, you can look for this. You can check out this course. They have an agent course as well that I recommend if you are into it. And that's it for today. In the next video, we will talk about the tokenizers. Thank you for watching. See you in the next video. May the force be with you.